logical operators are AND, OR, XOR, NOT. This and symbol ampersand. It is logical AND operator between two conditions. A and B are two conditions. If the result of condition A is true and result of condition B is also true, then only this complete statement expression's result is true. True means non-zero, false means zero. In case of OR operator, if both conditions are checked, but if any one of the condition is true, then the result is true. If both conditions are false, then result is false. NOT operator reverses the statement. If it is true, it makes false. If it is false, it's true. So for reversing the condition, NOT operator. There are also bitwise operators. Bitwise operators operates on single bits. NOT operator means 0 to 1 or 1 to 0. So if this is the number A, then every 1 is made 0, every 0 is made 1, and the new number is generated as a result of NOT operation. So when you say not A, you get this result if A is this. In case of AND operation, if A is this value and B is this value, and if you say A and B, then this value and this value both are ANDed together to generate the value. And for that, the truth table is, if any one is 1 or both are 0, then the output is 0. When both are 1, then output is 1. So if anywhere there is 0, the result is 0. So 1 1 is 1, 1 1 is 1, but 0 0 0, 1 0 0. So wherever there is 0, the result is 0. When both are 1s, the output is 1. In this way, the result is generated. In case of OR operation, if any one is 1, then output is 1. When both are 0, the output is 0. And hence the result is generated. 1 1 1, 0 0 0, 1 0 1. So wherever there is 1, the result is 1. When both are 0, the output is 0. XOR operation is exclusive OR, where both 0, both 1 generate 0. 1 0 and 1 1, that generate 1. So this truth table is applied to every bit. 1 1, so 0. 0 0, so 0. But 1 0 is 1. In this way, the number is generated. So this is the result of XOR operation. There are also two more operations, left shift and right shift under this. Left shift is the number is shifted left by whatever number of bits given here. So here the number is this and it is shifted left by 2 bits. Shifted left means 2 left side bits will shifted out and the new number will start from this one and this is the new. And on the right side, extra places remain because of the shifting. So they are filled with 0 0. For right shifting, the data is shifted right. So rightmost bits gone out and from the left side, the zeros are added. Now let's see the use of logical operators in different applications through our compiler. So this is our compiler. So let's write some program. We know leap year. So let's write a program to check whether it is leap year or not. So user will enter the number. So say int here. Int here. Okay. Now we know the rules. First we must get the value of year from the user. Enter year. So user will enter the year. We must read this value of year. So let's read this. Here we have defined integer as it is a number. Okay. Now we know the rules. Year is leap if it is divided by 4 for all general years. So year has to be divided by 4. This is the first condition. So if year is divided by 4 means we know the operator percent, that is modulus operator. It gives us the remainder. If remainder is 0, then the number is divisible. So percent 4, year percent 4 has to be equal to 0. This is the first condition that has to be for the general operator. Now there is a special condition for century years, like 1800, 1900, 2000, 2100. For all these years, the condition is that the number is always divided by 100 divided by 4, but the year to be leap year, it must be divided by 400. So how to identify century year is, century year is always divisible by 100. So the year should be divisible by 400 and it has to be divisible by 100, and if the year is not divisible by 100, then in that case the year has to be divisible by 4. So for century years we have to take this care. So we will give a condition for century years that percent 100 should not be equal to 0, or percent 400 has to be equal to 0. This condition has to be there and this condition also has to be there. So we must put and. So it has to be divided by 400. At the same time, for this year, if it is a century year, then it must be divided by 4. If it is not century year, then it is not divided by 100. So these conditions we have written. And under this condition, this bracket is matching this bracket is matching this, and the overall for this AND operator, we must put the combined bracket for both for this. Now the condition is over. If this condition is followed, then printf, the year is leap year. Leap. If the condition is not followed, then else. We have to print that it is not leap year, no leap. Not leap. Now let's try this program. Enter year 2020, leap year, correct. 2019, the last year, not leap year, correct. Let's try one more. 2000, leap year, correct. Suppose 1998, not leap year, correct. Now century year which is not leap, we will check. 1900, not leap year. It is a century year divided by 4, but still it is not leap. So the result is coming correct. Okay. Now let's do something else. Let's get character from the user. So let's define character, suppose K. Get this character from the user. So K is equal to, this char. So we have got the value of. Now what we have to do is, the character could be anything. It can be alphabetical, alphanumeric, etc. Check if the character is vowel or not. That is the first. We want to check if it is vowel or not. So we will give a message to user that user should enter only alphabetical character. User may enter any character, but we will check only vowels. So printf enter alphabetical character. Alphabetical character. Okay, backslash n. This will be the message for it. Now we have got it. We have to check whether the character is vowel or not. Vowel or not. So vowels are A, E, I, O, U, capital or small. So a big condition we have to do. If now a big condition. Character is K. Not equal to capital single capital. This is the first condition. K is equal to. If it is equal to capital, K is equal to capital. Okay. Now let's check whether character is small e. It can be small e also. So or K is equal to small e. This is the next condition. Or we have to use these conditions for all the characters. So Control C. After bracket so capital A, small a, then capital E, small e, then capital I, small I, capital O, small o, and U, capital U, K is equal to small u. All these conditions we have to check. So this bracket, see, it's small, and this bracket, if you say, it is matching with this one extra bracket has come. So this bracket is matching with this bracket. So this is all the condition. If this condition is followed, then printf it's vowel. It's vowel. If the condition is not satisfied, then else it's consonant. Printf it's consonant. So it will print like this. Okay. What happened here? Why this symbol is there? Yes. This has to be matched. Okay. Now let's run this. Enter alphabetical character. Suppose I enter R. It's consonant. Very good. Suppose I enter A. It's vowel. Very good. Suppose I enter capital Y. It's consonant. Suppose I enter capital U. It's vowel. Very good. It's working fine. Now let's do something else. Let us read the characters from the user and print them as it is as a string. So let's define character K and tell the user that user should press a character. Then we will read every character and print every character. So user will go on entering this printf, enter characters, enter statement suppose. Whatever statement user wants to enter, user will enter. Okay. Now statement is a string, it consists of characters. These characters may be alphabetical or numerical or special characters. We have to read all the characters and we have to print all the characters. So to read the characters, we'll say that K is equal to J. So we read the character. To print the character, we'll say that put K. So K will be printed. Okay. Now here user will go on entering the numbers. This program will be there for single character, but we want to read a complete statement. So we must read every character of the statement until the end of line. How to understand whether end of line has come or not? That is with new line. So until the character is new line, we have to do it. So while K is not equal to \n, because \n is the head of line. Do this. You have to do this while it is okay. So okay. So why the red line? Some error? Yes. This should be starting point. Okay. Why this red line here? One more we want. Yes. Now I think there are no errors here seen. So let's run this. Enter statement. Suppose I enter something very good. Very good. Enter. So it displays very good. So each character is entered and each character is printed. Okay. Now in these characters, whenever we press any character, actually its ASCII code goes inside. And we should know that ASCII codes if you understand, then for capital A to capital Z, the ASCII codes are from 65 to 91. Okay. And for small a to small z, the ASCII codes are from say I think 97 to 97, 122. These are the ASCII. So remember these figures: 65 to 91 and 97 to 122. So let's come to compiler. Now we will get the statement, get the number here, and let us write a program to convert the statement into capital or convert the statement into lower. So lowercase or uppercase. When you type in Word, there is an option that your typing should be in lowercase or uppercase or sentence case like that. So similar program we are trying. So when you get a character, check whether the character is small. If the character is small, then make it capital. Or first write for making small. Then if the character is capital, then make it small. So capital character means K is between the range 65 to 90. So if K is greater than 64, that is 65 onwards, or K is less than 92, that means up to 90. If this is the condition, K is less than 64 or greater than 64 or less than 90, that means K is capital letter. In that case, we have to make it small. Now let's come here. Find the difference between this and this. 65 to 97. The difference is of 32. So 32 we have to add here. In that case, K is equal to K plus 32. So whatever is capital character, that will become small character. So everything what you type in capital, that will become small. If it is already small, will remain small. If it is numbers or special characters, they will remain as it is. Enter statement. I purposely enter the statement consisting of different characters. So I suppose am fine, comma, space, how are you, capital U, question mark. Now this is my statement. It consisting of special characters, space, numbers are not there. We can add the numbers also. Suppose some number is here. How are you? Now we cannot add. Here we can add 34 and then enter. What mistake has happened? Let me check. Yes, number has to be greater than 64 and less than 92, both. So we must put here actually and. Number has to be in this range, not either 64 greater than 64. It has to be both within the range. So let's run the program again. Enter statement. I have to enter it again. I am some number 56. Then how are suppose y o u suppose question mark. Everything has become in small. Every capital letter has converted to small. So this is, we have converted the statement into lowercase. If you want to convert into uppercase, then what is the condition? The number has to be greater than 97 or it has to be less than 122 and the number will be minus 32. So that small letter will be converted to capital letter. Now let's do it again. I will enter some statement. We are learning C 23 students, suppose. Students. Okay, converted. See, we are learning C 23 students. So whatever is there, it has converted to capital. Okay, so in this way we can use this AND operator, OR operator, all the logical operators.